From warehouse to starship, designing, prototyping, assembling, and testing. Phoenix in the real world, preamble. The day the starship needed a tape measure, the wizard had spent a great deal of time thinking about impossible distances. Mars, Jupiter, Saturn, the outer planets. Perhaps someday the stars. He had thought about relativity, artificial intelligence, radiation, propulsion, life support, robots, farms, workshops, medicine, civilization, and the strange philosophical question of what it would mean for humanity, finally to become a species living on more than one world. 2 books had grown from those thoughts. Book 1 asked, what must a starship contain? Book 2 asked, how could that starship become self-reliant enough to support human civilization far from Earth? Then something wonderfully ordinary happened. The wizard went looking at warehouses. Suddenly, the stars had to meet the loading dock. 3 companies and 1 very large idea. The wizard had been wandering through his local area looking at commercial properties that might someday provide a common home for 3 enterprises. Global Robotics Corporation, where advanced robotics, artificial intelligence, instrumentation, electronics, and experimental engineering could be developed. Interplanetary Trading Company, where materials, equipment, components, surplus goods, logistics, sourcing, warehousing, and trade could be handled. And Global Handyman LLC, where practical fabrication, construction, repair, installation, modification, maintenance, and the thousands of ordinary physical jobs behind ambitious projects could take place. The wizard liked the combination. 1 organization could invent things. Another could find and move things. The third could fix things. That sounded suspiciously like the beginning of a shipyard. The properties he examined contained wonderful open warehouse spaces, concrete floors, steel structures, loading docks, truck access, roll-up doors, electrical service, storage areas, offices, places where forklifts could wander around carrying things that weighed considerably more than Dizzy. And that was when Dizzy asked the question, "Wizard? Yes? How big is Phoenix?" The wizard stopped. Shadow the cat, had she been present, probably would not have considered this mysterious at all. Cats understood dimensional engineering perfectly. If the cat fit into the box was large enough. Humans had somehow complicated the subject. We forgot to measure the spaceship. The wizard thought about the question. For 2 books, they had discussed Phoenix as though everybody somehow knew what Phoenix looked like. There were crew quarters, a bridge, a medical bay, a workshop, a farm, airlocks, storage, computers, life support equipment, water tanks, power systems, scientific instruments, propulsion, robots, spacesuits, small auxiliary spacecraft, and enough machinery to keep a small community alive millions of miles from the nearest hardware store. But how big was the thing? 30 feet? 60? 100? Was Phoenix shaped like an aircraft? A submarine? A cylinder? A collection of cylinders? A central spine with modules attached? Could it fit through a warehouse door? Could it travel down a highway? Could a tractor-trailer carry a section of it? Could it be assembled indoors? Would the completed spacecraft have to be assembled outside? Or perhaps Phoenix should never be completely assembled on Earth at all? The wizard looked at Dizzy. "You have discovered a rather serious omission." Dizzy smiled. He enjoyed discovering omissions considerably more than fixing them. The boat in the basement. The wizard remembered an old practical warning. Never build a boat in the basement unless you already know how you're getting the boat out. It was funny until somebody actually did it. Then it became architecture. Phoenix had exactly the same problem. Suppose they built a beautiful spacecraft inside a warehouse. Suppose the finished vehicle measured 18 feet wide. Then suppose the largest door measured 12 feet. Congratulations. Humanity had constructed its first interplanetary storage shed. The spacecraft could explore approximately one warehouse. The wizard therefore wrote the first rule of Book 3, design the exit before building the ship. That single sentence changed the entire Project Phoenix discussion. The warehouse is part of the spacecraft. A spacecraft manufacturing facility could no longer be thought of simply as a building. Its dimensions became part of the engineering problem. The wizard began listing questions. How wide are the doors? How high are they? What is the clear ceiling height? Are there beams hanging lower? Sprinkler pipes? Lights? HVAC ducts? Can a crane operate above the vehicle? What loads can the concrete floor support? Can tractor trailers turn around? Is there a dock-high loading area? Is there also a grade-level drive-in door? Could a large lowboy trailer enter? Could a mobile crane reach the assembly area? What happens when the finished module reaches the public road? Are there bridges? Sharp turns? Power lines? Weight restrictions? The wizard laughed. They had spent months worrying about navigating between planets. Now they had to navigate the parking lot. That was engineering. Book 3. Books 1 and 2 had mostly concerned what Phoenix required to function. Book 3 would bring Phoenix down onto the shop floor. This book would investigate dimensions, geometry, modules, pressure vessels, structural frames, mass, center of gravity, manufacturing, assembly, joining systems, doors and hatches, shipping, cranes, fixtures, warehouses, machine shops, clean work areas, electronics laboratories, ground support equipment, power systems, propulsion integration, solar collectors, radiators, radar, LiDAR, antennas, sensors, external robotics, testing, transportation, and eventually the question that every prototype must face. How do we turn the drawing into hardware? Global Robotics Corporation, Robert Colee.